This is the first time Tesla has clearly demonstrated a first principles design philosophy, meaning not just making incremental adjustments from previous versions, but starting from the ground up, similar to how they completely reimagined the electric car when launching the first Model S. One of the key reasons Tesla had to redesign was the production scalability limitations of Optimus Gen 2. The previous design, while impressive in overall form, still relied heavily on manual assembly, with external casing components not yet standardized for robotic mass production. The joints used traditional welded and mounted parts, making full automation difficult. In contrast, Optimus Gen 3 features a monocoque exterior structure, which dramatically simplifies the manufacturing process. Elon Musk even revealed that this new version was designed for production of millions, not for display in a lab. Transitioning from a prototype robot to a truly commercial product requires not only technological advancement, but a complete structural redesign to ensure low cost and high scalability, something Gen 2 could not deliver. The second driving factor behind this redesign is weight and energy efficiency. Optimus Gen 3 is significantly lighter, weighing only around 110 pounds compared to the previous version's nearly 160 pounds. Cutting over 50 pounds not only allows the robot to move more nimbly, but also reduces material usage, lowers battery and mechanical wear costs. To achieve this, Tesla had to restructure the entire chassis, utilizing a combination of extruded aluminum, carbon fiber, and composite materials in areas like the chest and calves to maintain strength while minimizing weight. With the old design, reaching this weight level would have been nearly impossible without compromising structural integrity. This shows Tesla has fundamentally altered both mechanical logic and materials to pursue holistic optimization, not just for performance but also for large-scale production. Another key improvement is the optimization of maintenance and disassembly. Gen 3 is designed in a modular fashion, where parts such as arms, legs, face, battery, and sensors can be quickly detached using a few locking joints, similar to swapping a battery in a Tesla car. This allows for easy repairs, part replacement, and software upgrades, critical factors when manufacturing hundreds of thousands of units. In contrast, Optimus Gen 2 had a more rigid structure with complex assembly, making part replacement time-consuming and not well-suited for mass maintenance. Elon Musk once emphasized that a good product is one that's easy to manufacture, easy to maintain, and easy to replace parts. Additionally, the newly designed LED facial interface for emotion display and communication reflects Tesla's growing focus on human-machine interaction. This interface isn't just for aesthetics. It's part of a two-way communication system with humans, allowing the robot to convey emotions or send clear, simple signals without relying on speech. Unlike Gen 2's static dark faceplate, Gen 3 features a dynamic display, making the robot more approachable in environments like restaurants, factories, or hospitals, places where emotional interaction is indispensable. This is a strategic step toward turning Optimus into a companion, not just a mechanical tool. Another strategic reason behind the full redesign is to fully leverage Tesla's existing EV supply chain and technologies. Gen 3 uses many components shared with current Tesla vehicles, such as the FSD chip, 4680 battery cells, high-efficiency mini-electric motors, and optimized gear drive systems. This parts-sharing approach allows Tesla to save on development costs while ensuring a stable supply chain and seamless integration of the robot into their existing production lines. In Genesis 2, the component overlap was still limited, making manufacturing more reliant on separate, complex supply chains. It's also important to mention AI and computer vision, central to the design overhaul this time. Optimus Gen 3 has been optimized to learn from real-world data and interact in real-life environments. This required a complete rethink of camera placement, sensor angles, thermal management, and data flow. Generation 2 had limited vision, using a fixed camera setup, while Generation 3 was equipped with flexible sensor clusters aligned with its head and face, enabling it to handle complex scenarios in both homes and factories. Tesla didn't just change the outer shell, they upgraded the brain and eyes to be more modern and adaptable to real-world settings. Finally, the full redesign of Gen 3 reflects Elon Musk's ambitious goal to reduce the robot's price to below $20,000, equivalent to a compact car. Achieving this goal requires more than just incremental tweaks. It demands a complete structural transformation. From die casting the frame, expected to use the gigapress like with the Cybertruck, to battery integration, to attaching limbs, All are guided by a single principle: designed for mass production, not for lab demonstration. The sleek, minimalist design of Optimus Gen 3 with minimal extraneous details reflects this vision. Tesla isn't creating a showpiece. They're building a platform to produce millions of robots at the lowest possible cost. How is Gen 3 optimized for low-cost production? The new design of Optimus Gen 3 not only marks a morphological advancement, but also plays a strategic role in realizing the goal of mass production at extremely low cost. A critical factor if Tesla is to popularize humanoid robots for every household and business. While Gen 1 and Gen 2 still carried many experimental features, the Gen 3 design has reached the level of standardization necessary for large-scale industrial manufacturing. One of the key improvements is the reduction of unnecessary mechanical components, alongside a complete redesign of the frame and joints so they can be assembled by robots instead of requiring complex manual labor, as was the case with earlier prototypes. This not only cuts labor costs, but also significantly shortens assembly time per robot, a vital factor for achieving production speeds of thousands or even millions of units per year. Tesla has stated that it is applying its electric vehicle manufacturing philosophy to Optimus. The fewer the parts and the fewer the steps, the lower the cost. On Gen 3, many components that previously consisted of dozens of separate parts, such as the hands, head unit, or torso frame, have now been re-engineered into integrated modules that can be cast or printed as a single piece using aluminum, composite materials, or fiber-reinforced plastics. This reduction in part count not only decreases weight and increases reliability, but also supports a fully robotic production line, where each module can be picked up, inspected, and assembled entirely by machines. This embodies the robots building robots vision that Elon Musk has repeatedly emphasized, and Gen 3 is the clearest manifestation of that vision to date. Moreover, Tesla has redesigned Optimus Gen 3 to fully leverage components and technologies already developed for its electric vehicle division, innovations that Tesla has spent more than a decade perfecting. A prime example is the shared use of 4,680 structured lithium-ion battery cells, wide-angle cameras used for FSD, full self-driving, thermal management systems, and real-time image processing software. As a result, Optimus is no longer an isolated product developed from scratch, but rather an extension of a mature hardware ecosystem. This provides two major benefits. First, significant cost savings due to economies of scale and existing supply chains, and second, improved reliability and performance because these components have already been battle-tested on millions of Tesla vehicles. In addition to hardware, the Gen 3 design also considers optimization of inspection and maintenance processes during mass production. Its modular architecture allows parts to be easily replaced or inspected, particularly suited to gigafactory environments, where every step must be precise and fast. For instance, rather than requiring the entire exterior shell to be removed to access control circuits like in previous versions, Gen 3 strategically places diagnostic ports and connection hubs in accessible locations. We appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.